So there are such things as even and odd functions. An even function, so a function is even if f of negative x equals f of x. In other words, say you had something like this, and you had a point here at 1, 1. It would mean that in order for you to be able to have a point at f of negative 1 must equals f of 1. So negative 1 must equal 1, meaning the y value for x must be the same as the y value for negative x. This is what makes a function even. For a function to be odd, f of negative x equals negative f of x. So this looks like, again, say you had a point at 1, 1. If it were at negative 1, the y value would be the opposite, or the negative, of 1 in this case. If it were at 2, 2, then negative 2 would also have a y value of negative 2. In this case, the function is odd. So the definition for these twos is, so for even, it's a function f is even if for every number x in its domain, the number negative x is also in the domain, and f of negative x equals f of x. A function f is odd if for every number x in its domain, the number negative x is also in the domain, and f of negative x equals negative f of x. So in an earlier video, we learned about symmetry with respect to the x-axis, the y-axis, and the origin. If a function is even, it has symmetry with respect to the y-axis, this axis. And every point x has a point, negative x, and the same y. If a function is odd, it has symmetry with respect to the origin. Every point x has a point negative x. And if x has a value of y, then negative x has a value negative y. In other words, if a function is even and it has the point xy, that means it must also have the point negative x, y. If a function is odd and it has the point x, y, that means it must also have the point negative x, negative y. Now say that you don't have the graph of a function, but you do have the equation. So let's take f of x equals x squared minus 5. How do we know if this function is odd or even? Well, if we plugged in negative x for x, negative x squared minus 5, f of negative x is x squared minus 5. This means that since this and this are the same, f of negative x equals f of x, which looks like the definition for an even function. Now let's take the function f of x equals x cubed minus 2. Plug in negative x for x, negative x cubed minus 2. F of negative x equals negative x cubed minus 2. Now, this and this, it is not the same, so we know that it can't be even. So we see if it's odd. In order for it to be odd, however, this portion would have to look a little something like this. Negative x cubed plus 2, because every single portion of this has to be the opposite of what it was before. So this means that it is neither odd nor even. Now let's take the function f of x equals 5x cubed minus x. Plug in negative x. For x, 5 of negative x cubed minus negative x. F of negative x equals negative 5x cubed plus x. If we were to take out a negative from this, since it obviously isn't the same as this, so let's see if we can take out a negative from both sides. If we took out a negative, this would become 5x cubed, and this would become minus x, or negative x. So, since we can take out an entire negative from this whole thing, and have this be the same as this, we know that this function is odd. When looking at a graph, it can be increasing, decreasing, or constant. Say we had a graph like this. This graph would be increasing since it's going up the whole time. This graph would be decreasing, and this graph would be constant. So here are more precise definitions. If a function f is increasing on an open interval I, if for any choice x1 and x2 in line L, with x1 being less than x2, meaning the value for x1 is less than the value for x2. So say x1 was 1, x2 would have to be more than 1. The y value for x1 and the y value for x2, f of x1 must be less than f of x2, meaning the y value for x1 must be less than the y value for x2. Now, if a function f is decreasing on an open interval I, if for any choice of x1 and x2, in which x1 is less than x2, the y value for x1 must be greater than the y value for x2. A function is constant on an open interval I if for all the choices of x, so every single x, the whole domain, the values of f of x are equal, meaning every single value of y is the same. Meaning that in order for a function to be constant, it must be a horizontal line. There's also something called local maximums, and of course, minimums. So, if we look at this graph, the local maximum would be right about here. And let's say that the ends are open. Now if we look at another graph, the local minimum would be right here. Maximum is the highest point, meaning that points on either side of this point right here, the y value has to be lower than that point. For a local minimum, the values on either side of this value have to be higher. The y values have to be higher than the y value for this. Or if we use the vocabulary that we learned just now, on either side of a local maximum, it has to be increasing to the left of it and decreasing to the right of it. With a local minimum, it must be decreasing to the left of it and increasing to the right of it. Okay, so if we look at this graph, does it have any local maximums? Yes, it does. Right here at 1, 2. Why? Because on either side, the y values are less. And to the left of it, it is increasing, and to the right of it, it is decreasing. What else? Does it have any local minimums? And again, yes it does. Here's one, and here's another one. To the left of the local minimums, it is decreasing, and to the right of it, it is increasing. And so we've already drawn in the arrows for when it's decreasing and increasing, but let's just write out when it's increasing, what intervals. So from this point right there, so that's -1, to this point right here, 1, and then from this point right there, 3, up until positive infinity, because as this arrow indicates, it goes on forever. Now for decreasing, so we go from negative infinity, since this goes on forever again, all the way till -1, which was this point right here, and then from 1 to 3. Okay, so earlier we learned about slope. Now we're going to learn about something called average rate of change, which is pretty much the same thing as slope. However, with this, we're going to try and find the average rate of change of a function. So the formula for this is delta y over delta x, which can also be written as f of b minus f of a over b minus a, given that a does not equal b. Now a and b are 2 points, 2 x values, and if we just plug everything in, that is how we find the average rate of change, or the slope of a function itself. And since we know that most functions don't look like this, they usually look something more along the lines of this, the average rate of change aims to find the slope in between 2 points. Let's try it. Take the function f of x equals 3x squared minus 3. Now, let's say our 2 x's were 1 and 4. The function was f of b minus f of a over b minus a. So in this case, it would be f of b. F of b is 4 plugged into the function, so 3 times 4 squared minus 3, which is 45. So f of b, 45, minus f of a, which is 3 times 1 squared minus 3, 0, over b, which is 4, minus a, which is 1. So we have 45 over 3. And simplify that. 45 divided by 3, 15. That is your average rate of change for the graph of 3x squared minus 3 in the interval 1 to 4. So now, seeing that the average rate of change is a slope in a graph, let's say we had found the average rate of change between these 2 points. Let's say this is -1 and this is 2. There's actually a line that goes through the 2 points whose slope, m, equals the average rate of change. I'm just going to write R to C short, meaning that this line, which is called the secant line, the slope of the secant line equals f of b minus f of a over b minus a. Look familiar? Well, this is the equation for the average rate of change. Okay, so let's say we try and find the equation of the secant line. Let's take the graph f of x equals 3x squared minus 2x plus 3. Let's say we go from -2 to 1, well, f of b minus f of a over b minus a. So b would be 1 minus a, which is -2, since we always go right to left for the 2 points. So then f of b would be 3 times 1 squared minus 2 times 1 plus 3, which is 4. And f of a is 3 times -2 squared minus 2 times -2 plus 3, which is 19, 4 minus 19. So then that will turn into 15, and this will turn into 3. So this will equal 5. Okay, so now that we know that the slope of the secant line is 5, we can use that using the point slope form to find the equation of the secant line. So point slope form, y minus y1 equals slope times x minus x1. So y minus, if we remember our points from earlier, one of them was 1, 4. So now if we just use that point, y minus 4 equals the slope which is 5, x and x minus 1. So now if we just simplify, y minus 4 equals 5x minus 5. So isolate the y equals 5x minus 1. And that is the equation for the secant line.